All right, so here's example 3 from the notes from today. This is definitely something that we should know how to do. It's something we did in a previous lesson. We just didn't have time today. That's why we skipped it. So first things first, it says that the sixth term of an arithmetic sequence is 36. We don't know the seventh term, and we want to know how that gets to the eighth term of 64. So to do that, we essentially have to find the average of the two. So we're going to subtract the 2 and then divide by 2. So we're dividing by 2 because there's 2 places after the 6. So if we do that, we wind up having an answer of 50. This one's a little bit easier to figure out because the difference between those is 28. And then if we divide 28 by 2, we wind up getting a common difference of 14. For the geometric sequence, this is where things get a little bit more difficult. So for a geometric sequence, there's a common multiplier. So we're trying to multiply something by itself a few times to get to the next term. So if we know the sixth term is 36 and the eighth term is 64, if I divide the eighth term by the sixth term, I'm not necessarily finding the common ratio. I'm finding the common ratio times 2. Or times itself. So if we do 64 divided by 36, we get a fraction of 16 over 9. So that's the common ratio squared. So if I want to figure out the common ratio, not the common ratio squared, I would take the square root of that. So the common ratio is going to be 4/3. So to get to the seventh term, I would take 36 and times it by 4/3. So the seventh term of the sequence is 48, or negative 48. The reason why it could possibly be negative 48 is because geometric sequences alternate from positive to positive. This would be the negative in between those two positive terms, or they could all be positive. Number 4 we did in class. Number 30 I did in one period but not the other, so I'll show it here. If you were in period 3, you could skip over number 5 unless you want to see it again. So it says the first row of a stadium has 300 seats, so row 1 would be the first term. And it says each row after that is 14 more seats. That tells us it's arithmetic. So I know the second term would be 314, and the common difference is 14. So it then says to write a recursively defined sequence and an explicitly defined sequence to represent the number of seats in the nth row. So because it says that, I can't use n plus 1 for the recursive sequence. I just have to use a sub n and a sub n minus 1. So let's start with the recursive sequence. So the recursive sequence, we have to state a sub 1 is 300. And then we can say a sub n is equal to the previous term plus 14. This would be the recursive sequence. To find the explicitly defined sequence, since it's arithmetic, I know it's going to be a sub n is equal to the first term, 300, plus the common difference times n minus 1. Let's take a look at the homework. So for the homework, they want us to write a recursively defined rule and an explicitly defined rule for each sequence below. So let's take a look at the first one. I see that there's a common difference there. If I take 13.75 and subtract 7.25, I get 6.5. So because I'm getting 6.5, I know that this winds up being this winds up being a arithmetic sequence because you're going to get the same sequence over and over and over again. So the recursive sequence, we would say a sub 1 equals 7.25, and then a sub n plus 1 is equal to the next term, a sub n, plus 7.25. So the next term is equal to the previous term plus 7.25. That's the recursive sequence. The explicitly defined rule or sequence would be a sub n is equal to 7.25 plus the common difference, which was 6.5, times n minus 1. And this is actually 6.5, not 7.25. The decimals got confusing there. So don't let the decimals confuse you. So we have the next term of the sequence is equal to previous term plus 6.5. and any term of the sequence is the first term plus 6.5 times the term number minus 1. Let's take a look at the second one. I see that that's geometric because we have a common difference here that's not the same. I have 20 and then I have 25, so I don't have a common difference. So to find the common ratio, I would take the second number and divide it by the first number. So if I do 100 divided by 80, I get 1.25. Leaving it as a decimal is perfectly fine. So then to write a rule here, so I could say the first term is 80, the next term of the sequence is equal to 1.25 times the previous term, and the explicit formula would be any term of the sequence is equal to the first term times 1.25 to the n minus 1. Number 2 says a sequence is defined by a sub 1, and in the recursive sequence, 3/4 of the previous term equals the next term. Write an explicit rule for this sequence. So the explicit rule is going to be geometric. So it would be a sub n is equal to the first term times the common ratio to the n minus 1. Actually, no thought really needs to go into that other than that you know the difference between the two formulas. Because each formula has to give you the first term and the ratio. Number 3, Jenny planted a sunflower seedling that started out 5 centimeters tall, and she finds an average daily growth of 3.5 centimeters. This becomes arithmetic because it's going up by 3.5 every single day. It's not a percentage or anything like that that would make this geometric. So we know that a sub 1 is 5, and I know the common difference is 3.5. So a recursive formula would be a sub 1 equals 5, so a sub n plus 1 is equal to the starting value, or any value, sorry, so the previous term plus the common difference of 3.5. So we have the starting value and we have what we're changing each time. Number 4, a bouncy ball rebounds to 90% of its original height from the preceding bounce. Craig drops a bouncy ball from a height of 20. Find a recursive rule for the height. This becomes geometric. So a sub 1 is 20 feet. A sub 2 is going to be 90% high. So if we do 20 times 0.9, that gives us 18. So by just multiplying by 0.9, I'm going to get that 90%, right? This is one where I don't have to do any of the subtraction or anything because it's just 90% each time. So I know the ratio is going to be 0.9. So then what we could do is we could say the recursive rule is going to be a sub 1 equals 20, and then any number of bounces is going to be 0.9 of the previous bounce. Hopefully this video helps and you can watch it before tomorrow's quiz. Good luck.